is true. Okay, so which one's true, guys? Okay, and this isn't something I asked, but is it true that any irrational number, I can find another irrational number to make their product rational? What do you guys think? Is that true or false? Like for instance, if I gave you guys the number square root of 2, which is irrational, right? Is there a number that I can multiply that by to make it rational?
Square root of 2.
Square root of 2, right?
Yeah.
Or square root of 8, if I wanted to. Or square root of 32. So, yeah, because root 2 over root 2 is equal to 2, which is rational. How about pi? What could I multiply by pi to make that rational?
Square.
1 over pi.
1 over
Right,
pi.
guys? Because the reciprocal of that will be 1. Okay? Think of any irrational number. Couldn't you just take its reciprocal, multiply by it, and it makes it rational? In fact, that's the process of rationalization, if you guys remember. Okay? So it actually is a valid statement. Okay? So just in case you guys ever needed to do that, it is possible. Okay? We can prove that later in the course. Right now we can't prove it. Okay? But at least we know it exists. Okay? In fact, later in the course we are going to prove it for any irrational number. I'm going to show you guys a technique to do that. Okay. We're going to go ahead and do this one really quickly. So for all x and r, so what does this mean, guys? All real numbers. Okay? So for all real numbers, good. There exists, and I'm sorry, what did you say?
Irrational number.
Yeah, there exists some rational number, or a rational number. So there exists, we'll just say some rational number. Such that
The product of those numbers is not
the product is not an integer. Very nice. Such that their product is not an integer. Okay. And I'm going to give you guys a minute to copy that down. Good. So, easy enough, right guys? I'm just asking you guys to read off what we already know, okay? It's just like a computer program, okay? The first time you guys ever write a computer program, there's symbols, there's lexicons, there's all kinds of stuff that you guys have to be able to read and interpret. It's just like math, okay? As you guys keep getting further and further in your math careers, you're going to find that a math sentence becomes more and more dense, if you would. Like this is a pretty dense statement, if you would, okay? Because there's a lot of analysis to go on there, and that's what you guys are going to find, okay? John, go ahead, sir.
What is the x and y, like the difference between
Oh,
those, I guess? Like is x sum and then y is all, or is that?
what we're saying is that because x has the for all symbol before it, we're just saying that in the domain of real numbers, for any real number you want to exist, okay? So if you thought of a real number, like e or something like that, there exists some rational number, at least one. Because remember, e means that there is at least one, such that their product is not an integer, okay? And think about this. If I had the number e, if I multiplied that by a half, that would be e over 2, right? That's what we're saying, is that if I pick any real number that I want, and then I multiplied it by a particular rational, that means that it wouldn't be an integer for that, which is certainly true. Okay, that's all we're saying with that. Okay, does that help out a little bit with that?
So like y would be the 1/2.
Right, correct. This would be just some arbitrary but particular value that I pick. Okay?
Yeah.
And we're not, and again, we're not trying to prove it or disprove it. We're just taking the negation of it for right now. Okay? Yeah, don't get too hung up on proving or disproving. That's the next section that we're going to be looking at. Okay. Other questions, guys? Okay. Let's take a look at universal modus ponens and modus tollens. Okay? So we've worked a lot with modus ponens. We've worked a lot with modus tollens. Okay? They're all fairly easy, not meant to be too difficult. We know the form of modus ponens. Okay? P implies Q, P, therefore Q. Now, when we try to do this for the universal, okay, what we're doing is we're saying it's true for some particular A, okay? And A could be like dog, A could be, some sort of alcohol, whatever it wants to be, okay? It's just some particular instance, and we can plug it into that predicate, and it will be true no matter what. Same thing with modus tollens, okay? For any value in the domain, we have predicate implies predicate. If not the predicate for some particular value, then not the initial for that, okay? So our job is just to define these and see if it fits the form, okay? It's something that we've already done, it's not that big of a deal, but I just want to make sure that we understand how to do this, okay? So, let's take a look at this first guy, and I'll show you guys in particular how we're going to instantiate this. All right. So, if a number is negative, its cube is negative, which we know is true, that's not a big deal. X is a particular negative number, therefore x cubed is negative. Okay, so I'm betting most of you guys look at that and you're like, well, that's universal modus ponens. Okay, so we have P, which is this, we have Q, which is this looks like P, this looks like Q. So initially, most of you guys think it's going to work, and it will. Okay, we have to define our predicates though. Okay, so our predicate, let's call one of our predicates P of X. Okay, what would P of X be equal to? You have to be
Number
careful.
is negative. Number.
Okay, so we would say X is negative, right?
X is negative.
Since we're defining P of X to be an X, okay? So we're going to say X is negative. Nice. Okay. And then we also have a second predicate, which is Q of X. Okay. And how might we define Q of X in this instance? X cubed is going to be negative. Okay, good. So the cube of that number, we can say X cubed. I want you guys to notice that both of the gentlemen did not say if X is negative, then X cubed is negative. Okay, they just literally made a predicate out of this. Okay, so when you guys are doing these, don't use the words if and then. Okay, that's not a predicate. That's a conditional sort of thing. All right, so those are our definitions, and then we probably need to define what X is. So this is going to be X is a particular element of a particular domain. Okay. So what domain could you guys restrict X to? Not saying you have to, but one of the domains that will work. There's several.
Real number.
We could say X is a real number. What's another domain you guys could use? Integer value, if you wanted to. Okay, because it says it's going to be, well, not necessarily an integer. It just says it's a negative number. Okay, so I guess we couldn't limit it to integers in this case. So I think real numbers might be the safest thing to limit this to. Okay, so does that make sense, guys? When we're defining it, we have to define everything.
Wait, why can't an integer be negative?
Oh no, it can.
Yeah.
But we're just saying a number is negative.
Oh, gotcha.
Right, so an integer certainly could be negative, but it could be rational, it could be complex, etc. Okay? Does that make sense, guys? Any questions about that? So if I want to set this up, okay, just reading this, if a number is negative, then its cube is negative. P of X implies Q of X. I think everybody agrees with that. Okay. X is a particular negative number. So how will we write the second line there, guys? Not Q of X, but P of X, right? Because we're just saying X is a particular negative number. So this says, if X is negative, then X cubed is negative. We're saying X is negative, and X is a particular real number, okay? And X is a particular negative number. Therefore, what will be the conclusion? Oh, go ahead.
Wouldn't you have to put that on that where P of X is, you'd have to state that it's negative?
No, we're not, because what we're saying right here is that X is a real number, and we're substituting it back into this, okay?
Oh, you're just saying, you're defining X as
Correct.
negative already.
Yes, sir.
Right.
Okay? So by putting it into that predicate, we are saying that it is indeed negative. Okay? And remember, it's following a logical form. We don't know if it's true or false, but if it does follow that form, then it will be true. Or we'll see that it will be true. So, okay. And then, therefore, guys, what can we say is the conclusion?
Q of X.
Good.
Now, on universal modus ponens, we always have to define the domain, right?
You should define the domain of the instance that you're using.
Okay.
Okay? If you don't do that, then unfortunately it's not completely correct with that. Okay?
Okay.
And as you see a few more examples, it might make a little more sense.
Gotcha.
Okay. Is that okay with everybody, guys? Any questions? Okay. So now, this is obviously going to be true. It follows the universal modus ponens. So we're good with this. Okay? So we're going to say valid by modus ponens. Okay? That's all we have to do with this, guys. It's not meant to be difficult at all. Okay? Is that good with everybody, guys? Any questions? Okay. Sometimes it works, sometimes it doesn't work. Okay. So let's take a look at another example. Okay. So if a polyhedron has 4 sides, then the sum of the angles must be 360 degrees. Okay. The sum of the angles of a particular polyhedron S is 360, therefore S has 4 sides. Okay. So again, we're going to define some predicates. So let's start with P of X and Q of X. I don't think we need more than 2 predicates. Okay. So what do you guys think we define P of X as?
Polyhedron has 4 sides.
Not polyhedron, good try, but X has 4
4 sides,
sides,
yes, okay.
right? Because we're saying it's a predicate when we substitute values for X. Okay? So we would say X has 4 sides. Okay? Notice we didn't say if X has 4 sides or if polyhedron has 4 sides. Okay? Does that make sense to everybody, guys? Whatever variable you're using here, you better use on the right-hand side, just like a computer program, right, guys? If by the same fashion, what would Q of X be then? And there's multiple ways of stating this.
The sum of x must be 360?
The sum of X must be 360. Very nice. Good, Andre. So, the sum of X, whatever X might be, must be 360. Okay. So, does that make sense, guys? Any questions? We're just starting out with X's. There's one other thing we have to define. We have to define something that we're going to plug in for X. Okay? So what can we define first of all? Or what should we define by looking at our problem? S, right guys? We have a particular polyhedron S. So we're going to say S is an element of polyhedrons, right guys? Because that's the domain that we're looking at. We're saying a particular polyhedron. So S is a polyhedron. And now what we can do is we can start to build our universal modus ponens or Tollens, or see if it's an error. Okay? So at this point, guys, we can go ahead and finish this off. Okay? So, if a particular polyhedron has 4 sides, then the sum of the angles must be 360. Guys, wouldn't we agree that that would be P of S implies Q of S, right guys? Because now we're starting to talk about that particular polyhedron. Okay? And we're plugging that back into the predicate. So once we have our definitions, we just substitute them into the predicate. The sum of the angles of the particular polyhedron S is 360. Okay? So what would the next, the next line of this be?
Q of S.
Q of S, right guys? Because it says we define Q to be the sum of the angles, or the sum of X must be 360. So this is going to be Q of S. Therefore, what, guys? P of S.
P of S.
Nice. And unfortunately, this doesn't follow the modus ponens, or modus tollens, right? So this is invalid. If I was to ask you guys for a particular reason as to why this is invalid, and I know we looked at this maybe on assignment 1, but go ahead. Go ahead.
Inverse error?
Not inverse,
Converse.
but converse, right? Because that's okay. You had the right idea. Don't worry about it. Just don't do that on the exam. You'll be fine. Okay? Guys, notice that we flipped the P and the Q. Isn't that a converse error? Right, guys, when you flip those around? Nicely done, sir. So this is indeed a converse error.
Inverse will be like not P and not Q, right?
Correct. That would be not P of S, therefore not Q of S. Okay. All right. Questions about that one, guys? Okay. We could do the same thing for the next one. Okay. So the next one says all insects are small, dogs are not small, therefore dogs are not insects. Okay. So let's define a P of X and let's define a Q of X. And then we'd have to define something particular. Okay. So what's one of the 2 predicates that we could define here? These are a little bit sneakier. Was it? And X is an insect, maybe. How about that? Would that work, Donnie? Because we have to put it into the predicate form. Nice, okay. So let's say that P of X is an insect. So I'm trying to make sure I set this up nicely for you guys, so. Yeah, that'll work. So X is an insect. Okay. What would the other predicate be, you guys think? For Q of X? X is small. Okay, that sounds good. Because, and I know this one's a little bit more difficult because it's not an if-then, okay? We're going to convert it into one of the conditional statements, okay? So I like it. X is an insect, X is small.
Not small.
Now, well, no, that's the second line. We're still in the first line here.
Oh, okay.
Okay? Now, next we're going to get to the negation of this.
Got it.
Okay? Does that make sense, Art?
Uh-huh.
Okay. We need one more thing, right, guys? What's the only thing we need? We need our dogs, right? Okay? So, where are my dogs at? So, let's define D. Now, D-O-G-S, right? Not D-A-W-G-S. Okay? Like, suck dog with the drawn out all. Okay? We're just going for the mammalian. Okay? Alright. So, does this make sense, guys? Any questions so far? Now we can start to build our predicates. Okay? So, if I was to ask you guys to build this, okay, now be careful, okay? The first part says all insects are small, okay? How can I write that into a conditional statement? Because to show universal modus ponens or universal modus tollens, it has to be conditional. So, any idea how I might build that? So,
If X is an insect, then they are small.
So, if it's an insect, then it is small, right? So, in other words, if I wrote this, so would that satisfy what you were thinking? Yes. If X is an insect, then X is small, okay? Doesn't that make sense, guys? It says all insects are small,
No.
so we can convert that over, okay? Does that make sense to everybody, guys? I mean, it should just resound in your head that it's met the first part, so it has to follow the second part. Now we can start talking about the dogs. Okay? So it says dogs are not small. So